Given g of x equals 1 minus 2x and f of x is equal to the square root of x minus 2, find part A, f composite g of x and its domain, and then the harder part B, f composite f of x and its domain. Let's do A as a warm-up for B. Okay, part A, the 4 steps for finding the domain is step 1, find the formula of the composition f composite g of x. So that's f of g of x, where g of x is equal to 1 minus 2x. So it's f of 1 minus 2x. And the f function says whatever you feed me, take the square root of that minus 2. Simplify under the radical. We get the square root of 2x minus 1. So that is the formula for the composition function f compose g. Step 2, find the domain of that formula. Now that's a second root, an even index root, so we are required that the radicand under the radical sign has to be greater than or equal to 0. So the domain of this square root implies that the radicand negative 2x minus 1 has to be greater than or equal to 0. So solve that inequality for x. In the process of doing this, we'll have to divide by a negative 2, which causes us to flip the direction of the inequality sign. It becomes less than or equal. Okay, we had to flip the sign because we divided by negative 2. So there we have the domain of the inner function. Of the formula. It's everything less than or equal to negative 1/2. Step 3, find the domain of the inner function in f composite g. That means find the domain of g. The g function is the inner function in that composition. So we're looking for the domain of 1 minus 2x. That's the g function. There's no restrictions on 1 minus 2x. So the domain is all real numbers for the inner function. And finally, step 4, take the domain of the formula, which was the square root of negative 2x minus 1, and then intersect that with the domain of the inner function 1 minus 2x, and the resulting intersection graph will show us the domain of the composition f composite g. Now the only number of interest here is negative 1/2, so stack up negative 1/2 in line. And on the first graph, shade everything less than and also equal to negative 1/2 because that's the domain of the inner function, the domain of the formula. Then in the second line, we're going to graph all real numbers because that's the domain of the inner function. And then in the last line, we're going to take the intersection and just include common values in both of the sets above. That will include negative 1/2. That's why you have a boxy bracket. Interval notation, everything from negative infinity to negative 1/2 with a boxy bracket on the right. Set notation, all real values x, such that x is less than or equal to negative 1/2. So that's our function's domain, f composite g. Okay, let's go to part B. Here we're going to compose two functions together. They're both the f function. So step 1, now we have to find the domain, so let's work on that. Step 1, we are going to find the formula for f composite f of x. Okay, that's defined to be equal to f of x, so I'm going to write f, and I'm going to evaluate it at f of x. Well, f of x is the square root of x minus 2, so I'm evaluating f at the square root of x minus 2. Okay, so what is the definition of f? It is the square root of x minus 2. So they're saying whatever you feed into the f function, you take the square root of it minus 2. I'm feeding a square root into this function, so I'm taking the square root of x minus 2 and then subtracting 2 under the bigger radical sign, outside of the inner radical sign. Okay, so that is the formula for the composition f composed f of x. So the next step, step 2, is finding the domain of that mess, the domain of the square root of x minus 2, and then step outside of that radical and put minus 2 outside, but still under the bigger outer square root symbol. Okay, now we're going to have to do two things. If you just look at this function, there's got to be a restriction on the big radical, which means everything under the big radical has to be greater than or equal to 0 since it's an even index root. But then you have to go inside and see the second restriction. The second restriction is the stuff under the second little radical has to be greater than or equal to 0 also. So first let's deal with the restriction of the big square root. The radicand, the stuff under the radical sign, which is the square root of x minus 2 and then minus 2 outside, that radicand has to be greater than or equal to 0. So solve that for x by isolating the radical, raising both sides to the second power, and then moving the 2 over to the right side, you get x is greater than or equal to 6. Now that we are going to intersect together with the second restriction on the smaller radical. So what I would say here is that result, and in other words, intersected with the restriction on the smaller radical is that the radicand x minus 2, and that's all that's under the little radical, has to be greater than or equal to 0. So that gives us x is greater than or equal to 2. Okay, so we found the restriction on the larger radical for this formula is x greater than or equal to 6. The restriction on the smaller radical on this formula is x greater than or equal to 2. So the restriction on the entire formula is the intersection. In other words, all the values of x that live simultaneously in the domain of the big radical and the domain of the little radical. So the domain for the big square root of the little square root of x minus 2 and then minus 2 is equal to the x greater than or equal to 6 intersected with the x greater than or equal to 2. Together will give us our domain of the formula. So draw your stack number lines, line up the 2 and the 6. On the top one, shade everything greater than or equal to 6, boxy bracket. Second one, everything greater than or equal to 2, boxy bracket. Then the intersection is all the common shading, that's everything greater than or equal to 6, boxy bracket. Okay, so x is greater than or equal to 6. That is the domain of our formula. That's just step 2. Whew, wow. Okay, step 3, find the domain of the inner function. That's going to be easy. The domain of the inner function, it's f composite f, so the inner function is simply f of x. And the domain of the inner function is the domain of the square root of x minus 2. That implies the radicand x minus 2 has to be greater than or equal to 0 because it's an even index root, so x is greater than or equal to 2. Okay, step 4, the conclusion. The domain of f composite f is equal to the domain of the formula, which was, well, this is the domain of the inner function, intersected with the domain of the formula. I just said it backwards. I wrote them backwards. The domain of the inner function intersected with the domain of the formula. So stack your number lines together when you take the intersection. Line up your 2's, line up your 6's, shade everything greater than or equal to 2, shade everything greater than or equal to 6. And the result of the intersection, the common region, is everything greater than or equal to 6. So in interval notation, the domain of the composite function f composite f is boxy bracket 6 to infinity open bracket.